All right. Good evening, everybody. So my name is Kevin McKelvin, and I'm going to be speaking about Go in a polyglot environment, and a lot of this is going to draw from my work experience. So first up, what does polyglot mean? So the Oxford English Dictionary defines polyglot as knowing or using several languages. Now, I believe that this term has been quite appropriated by software engineering to mean someone that uses multiple programming languages to build a solution. And really, I think we're in an era of polyglot software. I don't think anyone really works only in one programming language for too long. It's rare to find software that's only built using one language. If you're working with web applications, you're most likely working with at least 4, probably 5 languages. If you include HTML, CSS, you've got JavaScript on your front end. You'll have some kind of query language to a database if you're storing stuff away. And your server will be written in a backend language. And I'm going to assume that around here, that'll most likely be Go. But even if you are using only an API, you're not doing any front-end HTML or any of that, and you're storing your data in memory, or it's ephemeral, it's being retrieved out of some other service, it's still likely that you're touching other programming languages. When you deploy your servers, your automation scripts, if you're using Chef, well, I don't know if anyone still uses that, but that you're going to be in Ruby, you're going to be in that range. Or if you're using Ansible, there'll be a lot of YAML around. Even if you're using modern stacks like Docker with Kubernetes, you're still describing things using different languages. And the reason that we're at this point where we've got all of these different languages that work well together is that the connect points are roughly the same size. Not perfect, but roughly the same size. What do I mean by that? So most languages are able to serialize data into something like JSON. They're able to make HTTP calls across to other services that may be written in other languages. If you use an analogy of Lego blocks, the blocks are roughly the same size, and the connect points are the same. And that means that we as developers are now free to choose the appropriate tool for the problem at hand, whether that would be Go for a compiled application, if you want to use some kind of scripting language. We are free to make these choices. And the case I want to make here is that I think Go fits very well into this environment. I believe that the design choices in Go and the tooling around Go have made it fit very well into this thought. So, for example, the design choices that Go produces a statically compiled binary, statically linked binary that contains all of its dependencies within it. That it allows for cross-compilation, that you can use Mac OS and compile for Linux, or the other way around, or for Windows, or for different architectures if you want to have x86 and go to ARM. You're able to do all of that. But that's all kind of tied together with a very rich, feature-rich, and very mature standard library that attracts people to Go and makes Go a good solution to problems across a broad range of areas. Combined with the fact that I think Go has some of the best runtime performance of a garbage-collected language, makes it a very attractive option. It plays well with other systems. It has very few barriers to entry. It drops those barriers. It attracts interest of people from other languages or who are building tools in other languages who are facing problems that Go solves well, and therefore drives adoption of Go. But who am I? Why would I be speaking about this? So, my name is Kevin McKelvin. I'm a Gopher JavaScript developer and a Rubyist. I'm CTO at a business called Resource Guru. And we've been running Go in production since the end of 2015. And this talk is going to illustrate a couple of examples, or illustrate the point by going through a couple of examples that we've had at Resource Guru. So This will make a bit more sense if you know what Resource Guru is. So Resource Guru is a time scheduling and leave management application for teams. It runs on the web. It's a tool that you'll use if you want to find who has availability for work to be done in your team, or to look to find out who has or who is doing something, who is doing what and when. Also to find out who's going on holiday, who's gone down for that ski trip that you've heard going around the office. But Resource Guru, let me go through the actual stack, well, a bit of a history. So we launched in 2012, and it was a Ruby on Rails code base exclusively. We built using Rails 3 back in Ruby 192 days, which is now about 6 years old, I would guess. And lots of CoffeeScript before ES6 was around, and believe me, lots of coffee. But what this meant, because we were working in a single language, we went for a platform as a service solution that focused on a single language. And Nginx gave us a hosted platform to deploy a Ruby on Rails application. And that meant that we were able to get out to production quickly and get an application live. But it did have a few drawbacks that caught up to us after a while. So since 2012, we then added new features to the application, we built it, we built the business, we grew our customer base, and it was all great until late 2015 when we started building a feature for tracking exceptions to availability. So let's say some person in your business is now working, or now for 1 or 2 weekends is going to be working on a Saturday, or has one day that they're working irregular hours, maybe putting some hours in, some earlier hours in and cutting out later hours. Before we built this, you could only track a standard availability for the entire week across people. This meant that we could now adjust for a specific day. Along with that, we were also building leave management, which kind of goes hand in hand, being able to mark when people are off on holiday. The result of this, though, was that instead of just assuming people's availability, it could now change day to day. And that meant that the complexity of aggregating time skyrocketed. We draw these reports across time, and that could be a year worth of time of people booked and people on holiday, people, projects that people are working on, clients that people are working on. As we were building this, with the extra complexity, we started seeing a certain thing happening to our Ruby process. Along with checking stopwatches, and after long enough, basically just explosions happening. What we were seeing is where reports would usually take less than 200 milliseconds to work for a whole year, we were seeing it taking up to a minute or 2 minutes. A lot of this has to do with Ruby's garbage collector and suboptimal algorithm that was built with active record, which is really built more for transactional work rather than reporting work. But that put immense pressure on Ruby's garbage collector and meant that we had these problems with performance. And that's pretty much what I looked like when I was looking at the problem. We had a few options on the table. Would we rewrite it in Ruby, because those were the tools that we were familiar with, but without active record, using Ruby struct? It's a pathway I had been down before in similar situations, and I knew that it would work, but it would also run into a cap at some point because of Ruby's global interpreter lock. So, okay, solutions outside of Ruby. Well, if we really wanted to hate ourselves, we could have written C extensions to Ruby for the complex part of the algorithm. Problem is, I don't know C, and I don't trust myself to learn C well enough to be able to write safe C that will run in production. And I think there were better options. So I had heard about this Go thing. I'd seen it at a Ruby meetup at the Johannesburg Ruby meetup. I'm South African, by the way. So I'd seen it at the Johannesburg Ruby meetup. One of the guys had come and showed us Go. And it looked really interesting. I didn't really know where it would fit in at the time. But it got me thinking to the point of, well, let's give it a try. So we took the approach of a tracer bullet. How many of you have read The Pragmatic Programmer? Right, so you'll be familiar with the idea of a tracer bullet. A tracer bullet from a real tracer bullet has the idea that it's a bullet in a gun that when you fire it, it leaves a trail that you can see. It glows and it leaves a trail so you can see whether you're hitting the target or not. When we move that metaphor over to software, that is a code base that is production quality code. It's not just a prototype. It's something that you build for production quality code that you want to see whether you just build the skeleton around it to see whether this would solve a particular problem. For us, this meant dealing with the complex parts of our algorithm, the things that we knew were slow, and just checking if this would actually work. That meant we had a tracer bullet application that would connect to MySQL, query our data, count up the available hours, the used hours and time off, and dump the JSON data just straight to standard out. Nothing too fancy, and there were definitely parts missing on this. Time zones, for example, which is every developer's nightmare. But anyway, so we saw that this would work. And we saw that a month of time that was taking sort of half a minute in a Ruby application was working in under half a second in Go. So that definitely pushed us in the right way. And we then decided to build our reports, our resource reports aggregator using Go. But we were on a hosted platform that only allowed us to deploy Ruby. So how do we resolve that? Well, this is where Go shines out, I think, in that it can sit well with other programming languages. We could build a statically compiled Go binary and package it up inside a Ruby gem, a gem being Ruby's package format. Put it into a private host on Gem Fury, and then call into that from our Ruby controllers. And that would go and call into the Go app and generate our reports. And we'd just dump it straight to standard out, and if it was an exit code 0, we knew it worked, and if it was an exit code 1, we dealt with the exception. Yeah, this is just bringing a hammer to the problem, quite literally. But it shows an interesting portable characteristic of Go. It can work well with inside environments that are controlled by other factors. Purely because all we needed to do is bundle up an ELF binary, write up a thin Ruby layer to run it, and call it. Now, it had some major drawbacks, one of which is connection pooling, for example. If you've got 10 Rails servers that are each calling into a binary that makes 50 connections over to MySQL, you're going to hit a point at some point where you're going to run out of MySQL connections. But it was a start. And when you're dealing with, or when you've got a feature that's pretty much ready to go, except for one last thing, you take that solution and then you deal with figuring out the more permanent solution later. So a more permanent solution was that, once we had realized that we couldn't live in an environment where we could only deploy one monolithic Ruby application, was that we started looking at other platforms out there. Early 2016 now, and Docker and Kubernetes were all over the Hacker News, right? And we successfully made a move off of EngineYard onto Google Cloud Platform's Google Container Engine in March 2016. Google Container Engine giving us a hosted Kubernetes environment. Once we had our application in Kubernetes, we then went and pulled it out of the binary, got rid of that binary code, binary gem, and turned it into a full-fledged HTTP service that could actually service user requests coming in. The purple is our max response time with the package gem. Blue being our maximum response time after we had switched over to having the application hosted in our Google Cloud Platform. But here's the thing. Now we've got two different services that users are hitting, but we don't want users to actually know the difference from the outside. They need to be able to interop with Rails, and we've got session cookies doing authentication, right? So when a user hits the Rails application or the Go application on the back end, we need to support that we need to be able to read that same session cookie. And Go had a package that we found that worked very well to decrypt the Rails session cookie, verify the signature, and then we could read out our user ID and all that information out of the session cookie. But moving things over from one service to another and then proxying things to different backend services meant that we ended up with this really ridiculous nginx configuration, and this is just a little extract out of it. Basically, every time we had a route that we moved over, we had to add another location block in nginx and add proxy information and figure out where that request is actually going to. Also, because we didn't have nginx running in development, we had a problem of dev and production parity that we were running into, where we had a Node.js script temporarily in development, and realized this is just not maintainable. So we took a crack at using Go to build our actual web server that serves user applications, replacing nginx as our point of SSL termination, and let that become our front-end edge of our site. So what we wanted to do is be able to proxy requests to our different backends using, by looking at by inspecting the HTTP method, the root, and more recently, actually, the host subdomain as well. So if we're doing a GET request to our bookings endpoint, we want that request to end up on an API box, which is one of the Go HTTP APIs, where if it's a post, that logic is still sitting in Ruby. So that needs to go to Rails. At the same time, we've got front-end assets. Well, this is now something that we've subsequently moved to a CDN, but it was a problem to solve at the time, was that front-end assets also needed to be served from different hosts. Thankfully, Go's standard library came to the rescue with httputil packages having a reverse proxy. Now, reverse proxy has a director function, which accepts an HTTP request, transforms it in some way, and then sends it on, and then returns the response to that HTTP request back to the original requester. So we went about writing some code to actually build out this configuration. We had backends, and we had directives to figure out which routes ended up at which backends. So a backend would be a protocol and a host. So in a Kubernetes environment, we've got our Rails applications. So that would be an HTTP request over to Rails. We had API that was just on the API domain, host name. And we then had directives that would be able to inspect a request and send that request to the correct backend service based on the HTTP method, the root, and the host. At the end of all of that, we just had to create a director that would consume our configuration and then call into the correct root at the end, that line 26 in the code over there. And then we could have configuration as code, which meant we could write unit tests that actually checked that this configuration worked, rather than deploying something and then getting a message back that we've forgotten a semicolon in an nginx config. This configuration can be tested on our CI server, that every time we make a change or we're moving a route or adding a route, that we can check that the front-end web server is actually going to handle that correctly. And we run that in development as well. So your dev and production get the exact same results. So that was a huge one. It also gave us a really good place to bring in global middlewares, as I say. So things like your HSTS headers, if you want to force clients to connect to your site on HTTPS, that can be served at the front-end server level, where we previously had that being served by Rails, as that was our application code. Similarly, we could put cause headers on our API, regardless of whether that API was being served from Ruby or from Go. Both of them could have the same cause middleware. And when Go went and implemented HTTP2, we just recompiled and got that for free, which is pretty cool. Future plans that we have for using Go in our stack. Well, we've been building new features using Go since we deployed that API. And it's been an incredible success story the whole way through. But we're happy to keep on building things using Go because we have no fear that they won't play well with applications that we've built in other languages. We're looking at gRPC. Just last week we put up our first service that uses gRPC to handle rate limiting. And we've had such a good experience on that it's again given us confidence in working with multiple languages and the ability to keep these connections going. gRPC bridges that gap very well between our Ruby app, for example, and a Go application that's controlling our rate limits. And the report generation that I told you about, well, at the moment it's just running in some Go routines on a single server. But one of the things that we can do now is distribute that across our entire cluster rather than just on a single box. So Go has been an incredible success story for us. We haven't had to go and rewrite the entire application just because we had one problem with Ruby. We could bring in Go just at the places where it made sense. And as it made more sense to build new features in Go, we could continue to build our application with an appropriate stack. Thank you for your attention. Are there any questions? Any questions? Was that clear? Right. Mind the beers?
So what was the hardest thing you found moving to Go, and what was the easiest thing you found?
Wow, where to go with that?
Language then.
Sorry?
More as a language rather than the surrounding technologies.
Well, I mean, the language itself, as a team, we found it very quick to adopt and to learn the language. It's a very simple language. Literally just by hearing a presentation and playing with it, looking at some examples and playing with it, it just worked, really. We had a really interesting comment at the point where we were building this. If it compiles, it generally seems to do what we want it to do. And that was a strange experience coming from a dynamic language. I'm trying to think what the hardest thing was. I think the hardest thing was getting it or deploying it into an environment that figuring out how to deploy it into an environment that was exclusively Ruby. But if you're using any of the modern tools now, if you're using Docker, everything looks the same from a server admin point of view, right? So I think a lot of those problems have been solved by tooling since then. Yeah.
there anything that you think you could not have done without using Go?
Without using Go, that feature would not have made it to production. The leave management, all of that, the things that we were doing with that, we were having performance problems, and we would still be having performance problems without Go. Giving us a platform where if things are running slowly, we have things parallelized, and we can just chuck a couple of extra CPUs at the VM, and it just suddenly runs faster magically. We couldn't do that where where we had Ruby that had that global interpreter lock. Ooh. Yeah.
Yeah, so you have answered actually you have answered the question already. How did you solve the transition in terms of resourcing? So did you cross-train your Ruby developers to Go, or did you hire? How did you start?
No, we just pretty much said, go work on this. And the Ruby developers, the team I'm working with, we're very happy to start going to learn new programming languages. Everyone was already interested in that kind of thing, so that did help. I think everyone on my team is a polyglot at some level, and was before we started working with Go. So learning a new language, that was actually one of the easiest things. Yes?
How much % is your Ruby stack after now adopting Go?
Ooh. I mean, I think we've still got probably about 75% of our code is in Ruby. But I'd say 75% of our requests are handled by Go. The hot parts are in Go.
How much would you like it to be?
Oh, 100%, no question. No, actually, in fairness, we've got services that are written in Node, that are written in Ruby, that there'd just be no point to make a changeover now. Yeah.
Hello. Yeah, so how do you find the differences in testing in Ruby and Go? Because I think in Ruby you can do RSpec to mock and stop things easier, but in Go, do you use any library to do that kind of stuff? Or?
The only library that I've added to the testing is